Welcome back. Time for a bit of a brain break. Let's talk about working with dates inside of Microsoft Excel. Dates aren't that hard to work with. In fact, there's a misinterpretation that because they're dates, they can't be manipulated the same way regular numbers can. That's not the case at all. Let's go ahead and start with something simple. Now, I'm going to go ahead and insert today's date. In this case, the day I'm creating this video is November 24th, 2015. But instead of typing that, I can let Excel do that because surely it knows, right? I can use the keyboard shortcut Control semicolon to insert today's date. Go ahead and try that for yourself. Once again, pressing and holding the Control key and tapping the semicolon key. Now, we fell into a coma a couple of days ago, or weeks ago, and we let a couple of bills slip past. Maybe we took a really long nap. Let's say that. Now we need to calculate how many days overdue we are so we can prioritize which bills are the most overdue and pay those first. Now how do I calculate that? How do I take the due date and find out how many days overdue any one particular bill is? Well, how would I calculate the difference in any other number? Let's say I had a number 15 and a number 11. If I wanted to calculate what the difference was between 11 and 15, how would I do that? Well, I would subtract 11 from 15. So why can't I do the same thing with dates? Well, really, you can. In Excel, they actually figured out a way to take two dates and subtract them. Just like with any function, we're going to go ahead and start with an equal sign. And we're going to take today's date, in this case, cell C1, and subtract it from the bill's due date, B5. Now, I have the foresight here to see that I'm probably going to autofill this down, so I'm going to go ahead and absolute reference that C1, meaning that I always want C1 to be the reference field. However, I do want B5 to become B6, B7, and so on. Once you've got this function up and running, go ahead and tap the Enter key, and there you go. So this bill is 10 days overdue. Now, that I've built that, I'm just going to go ahead and autofill down. Woof. Those poor guys at Comcast, they're hurting for that bill. Now, with that having been said, how does it know? How does it take a date and add and subtract it? Well, Microsoft had to figure out a way to turn dates into numbers. Go ahead and highlight all of the bill due dates here. And from the Home tab, find the number command group, and let's change the number formatting from custom to general. Many of you have seen this before, but probably by accident. What do these numbers mean? How could this possibly be a date? Well, it actually is. Microsoft had to figure out a way to convert dates into numbers that could be added and subtracted. So these are actually the number of days since January 1st, 1900. In this case here, this date right here is 42,322 days past January 1st, 1900. The same thing works for today's date. If I change the number formatting from custom to general, I see 42,332. So what's 42,332 minus 42,322? Well, it's 10. And that is how Microsoft figured out how to add, subtract, multiply, and divide dates. Let's try another one. Let's play the How Old Are You game. In this case, let's go ahead and start by typing our birthdays. In this case, my birthday, September 11th. I don't know if I should give you guys the year. We'll say 1980. So September 11th, 1980. And from here, now I'd like to calculate how many days it's been since birth. So how do I do that? How do I calculate how many days between this day and, let's turn that back into a date, this day? Well, the same way we calculated how many days past due these bills were. By subtracting. So once again, I'm going to start with my equal sign, and I'm going to take today's date and subtract the birth date, and tap enter. So it's been 12,857 days since my quote-unquote birthday. This is the actual birthday. This is not my birth year. Now, how do I turn that into an actual age? Well, how many days are in a year? Well, there's 365 days in a year, but there's also leap years to take into account every 4 years. So how do I take that into account? Well, I'm going to go ahead and start with my equal sign, and I'm going to take the days since birth divided by, let's see, there's 365 days in a year. Every 4 years there's a leap year, meaning that we're going to divide it by 365.25, meaning that for every 4 times we divide into it, that accounts for an extra additional value. This should account for leap years. And from here, I'll go ahead and tap the enter key. So according to this, I would be 35 years old. There you go. It's that easy. Working with dates in Excel doesn't have to be hard, and in fact, knowing how they work makes things that much easier. Go ahead and take this opportunity to try this out for yourself, and then join me after the break. Welcome back. So we're looking at names. Here on the left-hand side, we've got a last name column and a first name column. Now, we started doing this, interestingly enough, because of form letters. You know those form letters? Those letters you get that tell you your credit has been approved for a $10,000 gift card? Hooray! Well, we started separating first name and last name because of those form letters. However, we're starting to get smarter at that, and so we don't necessarily need 2 separate columns. But all of our old databases still have them segmented. So how do we bring them back together? We can use a text-based function. In this case, the text-based function is called concatenate. It's okay, you'll be forgiven for not necessarily knowing how to spell that one. Fortunately, we have the Formulas tab, Text Function Library. So placing your cursor here in cell E5, go ahead and click on the text dropdown, and thankfully, mercifully, there's our concatenate tool. So go ahead and select concatenate, and that'll pop that box up. So in this case, our text1 box is going to be first name. Okay, I'm with you so far. What's our text2 box going to be? Last name. Cool. All right. But as I'm looking at this here, I see that the formula result is giving me Howard Smith as one word. But Howard Smith isn't a name. What should have happened? There should have been a space in between. We actually have to tell Excel to put a space in. It's a very literal program. So go ahead and delete text2. And how do we inject a space? With a quotation mark, a space bar, and another quotation mark, indicating one space. So once again, the way we did that was with a single set of quotes, a space, and another set of quotes. Lastly, for text 3, we'll go ahead and choose the last name once again. And now we see the formula result is now Howard Smith instead of Howard Smith. Once you've done that, go ahead and click OK. Fortunately, we don't have to build that any more than once. We can simply autofill down by clicking and dragging. Boom. And there you go, concatenate. Pretty cool, right? There are plenty of real-world uses for this. This is just one common example. Another fun text function is the left, mid, and right functions. Here in the middle, I've got nevertheless. Now, nevertheless has 3 separate words in it. Currently, they're all residing in cell I8. So let's say I'd like to segment them out into their individual parts. Here in cell H5, I'm going to go ahead and insert yet another text function, this time the left function. The left function simply allows us to pull a number of specified characters starting from the left side of a given cell. The text box here is asking what cell is the word in this case, I8. Now by default, it'll pull just one character. However, in this case, I'd like to pull 1, 2, 3, 4, 5 characters in order to pull the word never out. So I'm going to go ahead and type 5, and there you go. So by selecting cell I8 and saying I wanted 5 characters from the left using the left text function, I'm now going to hopefully get the word never in this box right here. Let's click OK to lock it in. There it is, never. Let's go ahead and try mid. Once again, I'm going to go ahead and find my text dropdown, and there's mid. The first thing it asks for, just like with the left function, is where is the text? Well, it's in cell I8 again. Now this time, it's got 2 fields after the text, a start number and then a number of characters. So the start number is the number of characters from the left you'd like to start before starting to collect a number of characters. Now in this case, the first character is number 1. So how many cells do you want to skip before you start collecting numbers? In this case, we'd like to skip never. So we want to start 1, 2, 3, 4, 5, 6. We want to start at character number 6. Okay. How many characters from character number 6 do we want to collect? Well, if we're pulling the word the out of the middle of this, we need 3 characters. So starting from 6, we want T, H, and E. And there you go. In the formula result, we see the. And we're going to go ahead and click OK. The last function, right. So if left pulled a certain segmented number of characters from the left, and mid pulled a certain segmented of characters from the middle, go ahead and take a wild guess where you think you're going with this right function here. Using the text function library dropdown, we're going to find right. Just like the left function, it asks for us to start with where is the text. We've got I8. The number of characters it's asking for from here. How many characters from the right is the word less? In this case, it's 4 characters from the right. And there you go. Go ahead and click OK to lock it in. And there you have it. Never, the, less. All pulled from one cell. Pretty cool. Go ahead and take this opportunity to try that out for yourself. Hello, and welcome back. We're going to get right into it. When we're talking about working inside of Excel, there's a lot of different things that can mean. It can mean we're going to be typing a bunch of stuff into a spreadsheet. It can mean that we're analyzing reports as they're coming out of a database. It can also mean taking lots of reports from lots of different places and consolidating them into one small spot. The benefit to this, of course, is that we don't have to manually do it ourselves if we know how to do it. In this particular instance, I'm looking at database outputs for my Connecticut division, my Maine division, my New Hampshire division, and between all 3 of those, they're all tabulating the same things: software, training, maintenance, and miscellaneous expenditures for quarters 1 through 4. What I'd like to do is take all of these reports from all of these different sources and consolidate them here into the all division summary. So let's go ahead and take this opportunity to do just that. The first thing we're going to need to do is start here from the summary page where we'd like the output to be. We're going to go ahead and highlight all of these empty fields from item down to the 0 at the bottom of quarter 4 totals. We're going to highlight all of this because we'd like to maintain this structure from all of the different outputs. Now that we've highlighted these empty fields, go ahead and find the Consolidate Data tool. This can be found inside the shocking Data tab on the far right-hand side. with the word consolidate. Find that consolidate tool and give it a click. The first thing it's going to be asking for is what kind of function are we using? In this case, because we're consolidating all of these individual items into a single division summary, we're going to be summing. The next thing it's asking for is our first reference. We'll go ahead and start in Connecticut. Our first reference is going to include all of the heading items down to and including the Q4 totals. Once you've highlighted all of that, go ahead and click Add. And that will add Connecticut and all of those fields to the reference field. Let's go ahead and jump over to Maine for the next one. Conveniently, those dancing ants continue to remain exactly where we want them. So all I have to do now is click Add again. One last time, New Hampshire. Once again, everything is exactly where I need it to be. Of course, you want to double check that to be the case every single time. And we're going to go ahead and click Add. Having pulled from all three resources, in this case, Connecticut, Maine, and New Hampshire, all we've got to do now is determine where to use the labels from. And in this case, the labels exist in the top row as well as the left column, so both will be checkboxed. Once we've got everything up and running, verify that all references are in place, we're going to go ahead and click OK to lock this in. And just like that, everything has been consolidated into my all division summary from all three worksheets. We can verify by going to Connecticut, and let's say for Q1 software. Connecticut pulled 200. Maine, 400, that's 600 total, so New Hampshire must have 200. Coming out to 800 total. Check it out, that's pretty cool. Go ahead and take this opportunity to try it out for yourself. Once again, the way we got here was starting by highlighting where we'd like the output to be. We then turned on the Consolidate tool. From here, we selected each individual reference and clicked Add for each of the three state divisions. From there, we told it which labels to use, in this case the top and left column, and then clicked OK. Go ahead and try that for yourself and join me after the break. Welcome back. So now you've gotten a taste of consolidated data. Now that one worked really well, but it also had everything in the exact same order. So software was in the same place on every single sheet, and so was quarters 1 through 4. Let's talk about one where everything might not be exactly the same. Here I'm looking at consolidated sales data for Henry Albertson, Alan Patel, and Caroline Brenshaw. Now in each of these, they're selling different products in some instances, but even when they're selling the same product, it's not in the same place. So in this example here, we're not necessarily going to have the luxury of being able to highlight and select so that we can autofill it into some pre-formatted structures. Go ahead and place your cursor in cell A5 here. And we're going to go ahead and start with the Consolidate button once again. For reference, we're going to go ahead and start with Henry Albertson. Once again, we are going to include the headers. So in this case, the Albertson worksheet from cell A4 to C7. Once again, we're going to click Add. We'll go ahead and jump over to Alan Patel. Fortunately, the flashing marquee is exactly where we need it to be, and we can just click Add. Lastly, in this case for Caroline Brenshaw, there's a line missing here that wasn't missing for the other two. So we're going to need to readjust the flashing marquee, and then click Add. Once we've got all three references in place, once again we need to verify where the labels are. In this case, the labels still continue to be on the top as well as on the left. So with that having been said, go ahead and click OK. And there you go. It's that easy. Now let's verify to make sure that it matched up everything with what it should have been. In this case, now we see there are 4 lines. Now in none of these were there 4 lines. So already that's a good sign. Let's take a look at Encyclopedia. Henry Albertson sold $34. Okay. Oh boy, 54. So 34 plus 54, we're talking about 88. Meaning that should mean that Caroline didn't sell any encyclopedias because that's already $88. So I'm going to go ahead and jump over, and she did not. So that comes out to 88. And in fact, we can verify that with each individual item. It's actually verified each individual row value, identified it, and matched it up to give us our sales, summation, and commission. Go ahead and try that for yourself, and join me after the break. Welcome back. So, enough of the cupcake talk. Let's talk about something a little bit more substantial. In this case, transportation and shipping costs. Now, it's never too soon to prepare for the next holiday season. To optimize shipping costs, the following constraints must be put in place. Each of these plants must produce at least 20 units a quarter to justify remaining open. Charlotte has a maximum capacity of 92 units per quarter, Portland 45, and Quebec 55. Plant production must equal the requirements of the warehouse since there is a short shelf life. What is the lowest possible cost of shipping we can achieve? So once again, we're going to be turning to our solver tool to calculate this. In this case here, what's our objective? We're trying to calculate the lowest possible cost of shipping. So our objective cell is going to be the total cost once again. In this case, H7. Only now, instead of calculating the max, we'd like to calculate the minimum. The next thing it's asking for is, just like last time, what variable cells do we have? Well, in this case, we're actually going to be handing over all of this from B5 to E6. We're surrendering control of all of the product shipping. So B4 to E6 are the variable cells. With that in play, the next thing we need to do is simply implement the constraints. Because at this stage right here, the lowest possible option by changing these values is 0. So let's go ahead and add some constraints. Each plant must produce at least 20 units a quarter to justify remaining open. So something must be greater than or equal to 20. And in this case, this is specific to each plant in each quarter. So that's all the cells. B4 through E6 must be greater than or equal to 20. So that's our first cell reference. We're going to go ahead and lock that in by clicking Add. Charlotte has a maximum capacity of 92 units per quarter. So that's going to apply to everyone in Charlotte. Each of these cells at a minimum, or at a maximum rather, must have at least 92 units. So Charlotte, in each quarter, must be less than or equal to 92. Portland must be less than or equal to 45. And Quebec, with a maximum capacity of 55 units, must be less than or equal to 55 per quarter. The last constraint, plant production must equal the requirements of the warehouse since there is a short shelf life. This means that on each quarter, these fields must equal these fields. So in quarter 1, we absolutely have to create 180 units. Meanwhile, in quarter 2, we absolutely can only increase to 80 units. 190 for quarter 3, and 160 for quarter 4. This is our last constraint. So instead of clicking Add, we're going to click OK. This time now we have 5 separate constraints. That's a good chunk of change right here. Now there's really nothing left to be said except, do we have our objective? Sure. Minimize the total shipping costs. Do we have variable cells? Yes. Control how much output in each plant per quarter. And do we have the constraints? Yes. We've implemented all of them. No plant must produce less than 20 units per quarter. Charlotte must produce at a maximum 92 units. Portland at a maximum must create 45, and Quebec at a maximum must create 55. Now, each of these plants has its own shipping per unit cost. So now, the only thing that's left for us to do is leave it to Excel to find out exactly how much we should produce where. Go ahead and click Solve. And just like that, it is calculated that the lowest total possible cost of shipping is $1,011. In almost all instances, it seems to have overloaded Charlotte. Now, logic might dictate that we would try to overload Portland, but Portland has only 45 units max. So naturally, Charlotte, being the second cheapest shipping option, maxed out in nearly every quarter except for quarter 2 because of limited warehouse capacity. Microsoft figured all of that out by just implementing these constraints. Pretty cool. To restore back to original values, simply check Restore Original Values and uncheck Return to Solver Parameter Dialog, which brings us back to square one. Go ahead and pause the video and take this opportunity to try this out for yourself. I'll meet you after the break. Welcome back. So now that we've seen that there are some tools available that allow us to kind of offload this decision-making process to Excel, especially when it comes to just something as simple as consolidating data, it makes you wonder, what else can Excel do for us? For this next part, I'd like to talk about a tool that's actually not readily available inside of Excel. It's a tool called the Solver tool. As we're looking at this first example, it says the client is paying per item. Oh, we're a bakery now. Cool. The client is paying per item. Calculate the highest total cost we could sell the treats for. And then we've got some constraints. Oh. All right, I'm getting a little bit of PTSD back to my SAT days. Something about a train leaving a station and blah, blah, blah. I really don't want to have to make any sort of effort on this. Right? How would you even go about solving this? We need 400 desserts, at least 50 of each dessert. You can't have more than 100. How do you solve this? I wouldn't want to go through this process. And frankly, you don't have to. Excel actually has a tool available that's designed to solve complex questions like this with specific limited parameters. However, in order to use it, we have to go install it first. Now don't worry, you don't have to leave Excel. It's relatively easy to find. Go ahead and dive in with me to the File tab. Inside the File tab, go ahead and jump into Options. Once we've jumped into Options, we're going to go ahead and need to find the Add-ins tab here. Here inside Add-ins, we're going to need to find the Manage Add-ins and click Go. And it's here that we'll see the Solver add-in here at the bottom. Go ahead and checkbox that. And once you've checked it, go ahead and click OK. It only takes about a second to download, and once it's done, you'll see it here on the far right-hand side of the Data tab, the Solver tool. So let's go ahead and turn it on. Now, the Solver tool is an example of what we call what-if analysis, meaning that we can say what if it had all of these constraints and we were trying to find a specific output. The first thing we're going to need is to set an objective, meaning one cell that we'd like to control the output of. In this case, we're trying to control the total cost. We want to find the highest total cost we could sell the treats for. So our objective is going to be to set this cell right here to the highest possible option. So here, set the objective D8 to max. The next thing we're going to need to set are the variable cells. We're actually going to give control of some of these cells to Excel in order for it to determine what the best combination of certain cells are in order to get us the output we want. In this case, the highest possible. In this case, our variable cells will be the quantity of each particular bakery item. So the variable cells are going to be B4 through B7. Once you've selected B4 through B7, go ahead and click down and away. So our variable cells are going to be here. Excel is going to be able to control all of these cells right here. However, if we have it just go right now, the max could be anything. It'll just go on for infinity. We need to set some parameters, some constraints. And that's where this comes into play, subject to the constraints. Go ahead and find Add and give that a click. We've got the Add constraint box. So the first constraint, we need 400 desserts. Okay, so 400 desserts. What cell must equal 400? So I'm going to go ahead and change this to equals 400. Okay, what cell must equal 400? Well, it would probably be the total quantity of all desserts. So here, B8. B8 must equal 400. So now we're converting this sentence into an Excel phrased structure. Once you've put that into play, go ahead and click Add to move on to the next constraint. We need at least 50 of each dessert. Okay, so something must be greater than or equal to 50. What cells must be greater than or equal to 50? Well, it says each dessert. So that means all of these, cinnamon buns, cronuts, cheesecake, and brownies, must all be greater than or equal to 50. So here in the cell reference, I'm going to click and drag to select. B4 through B7 must be greater than or equal to 50. And I'm going to go ahead and click Add. The last constraint is that we cannot make more than 100 brownies. So something must be less than or equal to 100. And in this case, it says we cannot make more than 100 brownies. So this is specifically related to the quantity of brownies. B7 must be less than or equal to 100. Now that's our last constraint. So instead of clicking Add, I'm going to click OK. And there you have it. So we have our objective cell, meaning that we want to control this one cell and its output. By changing the variable cells, in this case, all of the quantity fields, Excel is going to be able to try all the different varieties of options here to find the maximum possible output for the objective subject to these constraints. No dessert may have less than 50. You must have less than or equal to 100 brownies. And all desserts must total up to 400. Once we've got all of these settings in place, the only thing that's left to do is solve. Deep breath. And check it out. So it calculated that it would need 50 cinnamon buns, 200 cronuts, 50 strawberry cheesecakes, and 100 marble brownies. So the maximum total cost possible with all these constraints in place is $1,525. Pretty cool. In order to get back to our original solver parameters, we're going to checkbox Return to Solver Parameters dialog, and we're going to click Restore Original Values. But it's pretty cool to see that we were able to set these conditions and it met all of them, and in a split second, figured out exactly what we would need in order to get the maximum desired output. Go ahead and select Restore Original Values and checkbox Return to Solver Parameters dialog to jump back. Go ahead and pause the video and take this opportunity to try this again for yourself, making sure that you follow through on all the individual steps. I'll meet you after the break.